Hi, everyone. Welcome to August's rendition of Learning Labs. I'm Kirby Koo, part of the marketing team here at Chainguard. Today we have the amazing Patrick Smith, who's going to be running us through Chainguard Images for AI. It sounds like we have a lot of people from all around the world, but lots of Texans in the house. As well as Californians from the UK and so much more. Oh, Sweden too. That's so awesome. And India, this is amazing. So, Paris, France, bonjour, or maybe bonsoir. Anyway, so I just wanted to let you guys know about a few housekeeping items. On the right side, you should see the chat where you can obviously tell us where you're tuning in from. There's also docs, the docs tab where things are linked, including our next learning labs, which is on WordPress, our GitHub static repo, our academy, and other things. And then also there's a Q&A tab where you can ask questions, and I will do my best to stop Patrick so that he can answer them during the presentation. But other than that, without further ado, I will give the stage to Patrick, and I hope you all enjoy the session.
Thank you, Kirby. All right, so I'm really excited to share this with you all because it's been a little while in the making. Let me make sure I can hear Kirby. Yeah, it's been a little while in the making, and I really think we have something cool here in these new Chainguard AI images. And looking forward to showing you why they're cool and demoing them for you. So I'm just going to go ahead and share my screen. We want the entire screen, which is always a risky proposition, but okay, that's what we're doing. Okay, we've got the terminal, and just a little about myself to get started. My name's Patrick. I used to run programming boot camps for Columbia. I've worked with James Webb, and I'm kind of a data guy. I like Python, ML. Also love, Wim Hof method. I heard there's someone from Stockholm there. Maybe hopefully they're into some of that stuff. Getting cold, jumping in a freezing lake. So if you're into that stuff, you could follow me, or what I want to show you today is our new PyTorch Chainguard image. You're going to need a couple of things before I start blah blah blahing. We're going to get a few things set up. Remember, these frameworks, AI frameworks, they're big frameworks. They're multiple gigabytes. And so we're gonna, in a second, start downloading or pulling our Chainguard image, so you can use it in the second half of this. But the other things you're going to need is some kind of Bash or similar ready environment. We haven't tested this on Windows, but if you're using WSL, try it out. And there's a chance you can create an issue later. So if something doesn't work, you're going to need to have curl and tar, so untar something. Probably you'll already have those utilities, hopefully, in your environment. Docker engine, you should have. So if you have access to the Docker command in your command line, you're good to go. And of course, you're going to need to bring your burning hatred of CVEs. If you don't know what a CVE yet, I'm about to explain it, but you should dislike those. They're bad. Okay, so hopefully you have all of these, and we're ready to move on. What we're going to do now is we're going to do a Docker pull command, and we're going to be pulling our PyTorch with the latest tag, or Chainguard image, AI image for PyTorch. So the command is going to be docker pull cgr.dev/Chainguard/PyTorch. Okay, and that will pull the production image for PyTorch. We also have a development image. I'll talk very briefly about that later. So it's sort of our hardened version. Yeah, let me just give you one little second to get that going. It will take a little while, but we're going to talk about a few other things beforehand. The general thrust of this presentation is going to be, we're going to talk a little bit about deployment security in 2024. We're going to talk about where Chainguard fits into that ecosystem. We're going to talk about the AI, state of AI and deployment, and specifically the PyTorch image. And then we're going to switch into demo, and we're going to train a model to identify 3 different animals related to open source stack, and then we are going to run that model in inference to detect whether a specific image is one of those 3 animals. And then by then we'll be done. Be time for Q&A. Okay. So hopefully you've gotten this started, that this is downloading. You got a terminal open somewhere. It's pulling. Hopefully by the time we get to that part, you'll have something. You'll have a nice pulled image to be ready to run that training. Okay. All right. So what is Chainguard? Or who are Chainguard? That's us. Chainguard is the safe source for open source. One of our philosophies is to shift left, really left, and we're going to talk about what that means in a second. And then our mission is to raise the waterline on software security, and software supply chain security. So come for the 0 CVEs, that beautiful feeling when you actually have no CVEs in your application stack. Stay for some serious hardening practices that go kind of pretty industry leading and go a little beyond what you might even be used to. Okay. What are CVEs? We don't like them. They're bad. CVEs are they're common vulnerabilities and exposures. They are a formal system that was developed in, I think it's the early 90s, to account for known vulnerabilities that affect software. And they have a long number assigned to them. Each one represents some issue with software that could potentially involve a vulnerability in your software stack. Okay. One issue with CVEs is because they're out there, they're known about, it's especially bad not to fix them. They are, because they can also be used by people, who might be scanning the web to do automatic hacks on your infrastructure or whatever. So you do especially want, CVEs aren't every vulnerability, but you do especially want to remediate CVEs. Okay, and so in this meme is the creepy little girl meme. Don't worry so much about this little girl. She did really well. She sold this meme for like $400,000 as an NFT a couple years ago. Okay, but your app is a burning building, and CVEs are the fire. Okay, so you want to remediate these. Oh yeah, of course. Oh yeah, hi. Nice. Okay, cool. Yeah, we don't want that. All right. So basically when you deploy an application, you choose a stack, right? You've got your software runtime, your language runtime. You've got application code. You've got that you might have developed yourself. You've got the operating system. And unfortunately, when you start developing your application, you are starting way behind. And why is that? Because even before you write any code, you may have dozens to hundreds of CVEs, critical, high, medium, low, all kinds of CVEs already registered in your application stack. So potentially, after developing your application, there may be a couple of CVEs, maybe 2, 3, 4, 5, that you've introduced to your stack, and then there may be dozens or hundreds that are actually in either the language runtime, the operating system, could be Ubuntu, could be Python, official image on Docker Hub, whatever. But all those, when you use a scanning tool such as Gripe, Triv, or any of the tools in this kind of software ecosystem that we have, software security ecosystem, they will be registering tons of issues of CVEs that you have. Basically, it's very difficult for you to remediate, because really, what are you supposed to do at that point? There's a few things you can do. You can keep your software up to date and so on. But a lot of times, these images are only built fairly rarely. They're out of date, and so there are fixed CVEs that are not actually integrated, or they may not be interested in fixing some of these. So what we do is, and we use this word shift left, and that really means that when you use Chainguard Images, and we'll talk about what Chainguard Images are more in a second, but when you use Chainguard Images, you typically start from something like 0 CVEs. Okay, it could be could be no CVEs, it could be 1 or 2 CVEs that are currently under remediation by our team, and that really lets you start from 0. And it makes things so much simpler, because when you see CVEs, chances are there may be something that you introduced or something, and it becomes much easier to fix your own CVEs. And it's not just that we flag them for you. They're remediated. They're fixed. And so just talking a little bit about what Chainguard images are. So they are low. We say low to no, often zero. And we'll talk about that special number 0 in a second. And is that like realistic? Just in a second. They are built overnight. So often we have we introduce patches or remediations updates to our Wolfie, which is our upstream OS, within 4 hours of them being available. And then overnight, they're pulled in, and the next day you have a nice, fresh, crispy image that's ready to go. And we deploy our images in different variants. So we have what we call a dev variant that is also secure in production, but that it has a lot of familiar. It's a more familiar structure. They have shells, package managers, and so on built in. But we also share and encourage you to use hardened images that do not have shells, package managers, or a lot of other affordances in software, text editors, and so on that are also a source of CVEs or even unknown vulnerabilities. So we encourage you to use those distro-less images as well. But let's talk about that magic number 0. So here is a comparison of the official Python image on Docker Hub on the left, and the number of CVEs that are currently in there. So you'll see there's a number of critical, there's high, medium, and low CVEs currently in the last 30 days. Over that time, we've basically been at 0 almost the entire month. Right now, this morning I pulled our Python image from our repository, took a quick look. I saw that there was one high CVE, which is actually relatively rare. All the other learning labs and so on I've done, they've been at 0. And I went on Slack and I saw they were already discussing that CVE. They had cherry picked a version upstream, and the patch had already been merged. So that's basically when we see something like that, we take full responsibility and we're on it. And with our images, we usually do 30-day software license agreements. So we have those CVEs remediated within 30 days, but usually far sooner. All right, so let's talk about 0 CVEs and like how realistic that is or not realistic. When I joined Chainguard, I was kind of like, 0 CVEs sounds like kind of like a marketing thing that maybe people say, but like, is it actually going to be 0? But it's actually really cool because they often are 0. And it's hard to believe. Vegeta can't believe it, and that other guy, but it's true. The scanners, when you run Gripe, Trivy, Docker Scout on our images, typically on any given day, and you'll get used to this pretty quick, you're going to see 0. And you're kind of sometimes surprised when you see 1 or 2, and you're like, oh, I wonder what's going on today. And when will those be fixed? Probably pretty soon. How do we do this? Well, we use the power of love, obviously, to fix all of our CV? No, we do not use the power of love. We work really hard at it. So there's the secret. We have a couple of quote unquote secrets. We're going to kind of share them with you right now. But really, the secret sauce is that we have a great team of security experts, language experts. They're working around the clock, literally, to resolve CVEs. And there's a couple of ways but there's a couple of best practices that we do have. Okay, and this is basically our formula. And people do find the 0 number pretty mysterious, just because people are so used to having CVEs that they're kind of like, is it possible? And is there a trick? But basically it's we start from an absolute most minimal image we can possibly have. And when you're going for 0 CVEs, you really think hard about putting any extra package in, because any given new package is a potential source of CVEs and actually unknown vulnerabilities too. So we really strip down, make our images as minimal as possible. Okay. The next thing we do is we build every day. So you're not going to see fixed vulnerabilities in our images typically. Okay. Or if you do see it, it'll be for an extremely short period of time. Okay. The other thing we do is we patch and we do manual remediations to fix things. That also involves, and then the other thing we do is issue advisories, because not every CVE is actually relevant to the image at hand. For example, maybe a CVE is issued for Windows architectures. We don't really support those, so we'll issue advisories saying, yeah, the CVE doesn't affect our image, and we're up on that. We actually issue those advisories. They get pulled into. We have close relationships with the scanner, the different groups that do scanner, Aqua security, and so on, and they pull in our advisories, and that's basically the formula. There's there's really no other way to do it except the hard way. So that's the hard way is how we do it. Okay, but now let's talk about AI, because that's really what you're here for. Okay, so, and specifically, let's talk about PyTorch, because let's not get too abstract. But I will say, in general, in AI, the other problems that you see with software are magnified, and that is because AI frameworks, they're big. I will also say there's maybe some cultural things. We're coming out of data science where they're not necessarily the most DevOps people yet. I think that's changing. But they're big. They're big container images. Okay, the frameworks are big, and then the images also contain a lot of extra stuff. Okay, so here we have have you seen this PyTorch image? And we'll talk about why you might care about that. But you might be like, oh yeah, let's just pull the official image from PyTorch. And it should be good, right? I mean, should it be safe? Unfortunately, it has some issues. It'll work, but there are issues. And just like Terminator guy here. And so basically, right now, yesterday, I pulled the official PyTorch runtime image. They do build in different varieties. Okay, so I pulled the PyTorch runtime image, which is the most minimal version they have, and so it has one critical, 5 high, 57 medium, and a whole bunch of low, 40 low CVEs currently. And the PyTorch image on Docker Hub only builds every maybe 5 weeks or something like that, I think is the general cycle. So, if you go look at the PyTorch on Docker Hub, you look at the tags, you look at the runtime, the last one that was built, you'll see it says about a month ago. Okay, and so maybe we'll expect another one in I don't know, a week or two, who knows when. And a lot of these CVEs, if you use gripe on them, it says, yeah, they're fixed. So basically over every month, the kind of number goes up. You'll have more and more CVEs, and they'll release a new one. Okay, we're back down, everything's fixed, and then it kind of starts again. So that freshness is also kind of an issue. And there's just a lot of surface area here. So let's compare our new PyTorch image with the official Docker Hub. And in terms of packages, and these numbers are a little controversial in terms of how do you measure surface area, attack surface in your images? And some people are like, well, files don't mean. I didn't include files here. Okay, we have a lot fewer files, but not every file is created equal. So remember that every package you put in is a potential source of vulnerabilities. So we have 75 packages, and they have something, I think, like 200 right now, packages in the official PyTorch image. And then in terms of executables, they're somewhere in the, clear the 1,000 range, and we're somewhere in the 400 range in terms of executables. So we just have a lot less stuff in our image. So that actually means, and that is relevant, it's not only for CVEs, though makes it much more maintainable, but it's also in terms of unknown vulnerabilities that you'd want to decrease the attack surface. Okay. All right. So we're going to kind of transition into the demo here. Hopefully you ran that Docker pull command. You got a nice image on your drive, and nice pulled fresh from the presses, built overnight PyTorch image. And you're going to go now, or we're going to go to this bit.ly link /CG-PyTorch. Okay, and this is going to have, it's a GitHub README page. It's going to have a couple of commands, and we're going to run them. And I will say, this is, I tried to create sort of a little bit of a royal road for you, because this is AI. We're going to train a model and we're going to run it. And those are, not necessarily the most trivial tasks in terms of showing off how an image works. So I've tried to create something that kind of just runs for you. That, not everything works. There may be issues. I will show you where there's a way to report issues here, because I want to get this, nice and stable for the next time I do this. So, but let's go ahead and open that. So we're going to do bit.ly. Hang on, let me pull it up. Awesome. CG. Kirby just let me know that she posted it in the chat. All right. Bit.ly cg PyTorch. And we got a nice, we got our nice commands here. I'll zoom in a little bit so you can see my screen more. So there's a couple of, now I will say, we have a nice getting started guide for this. So later, if you're more interested in doing this like interactively or going into more detail on what happens here, you can follow through that getting started. We also have a very cool AI course that I'll talk more about at the end of this that will cover some of this same material. But basically what I want, and also, yeah, if this doesn't run for you, we also have a link right here. You can create an issue, and you can just pop an issue in there, and I'll try to just try to be descriptive, share whatever happened in your terminal or whatever, and I will try to figure out what the problem is. Because these are very, big old commands. And so basically what we're going to do is let's run this command, and then I'm going to go back and discuss what all of this is doing, because this will take a while to run. And remember, I'll talk about why I chose to do this, but we're going to run this on CPU. So it totally will work on GPU, and I'll tell you how to do that. But I just assumed that a lot of people wouldn't necessarily have access to a GPU-ready, CUDA-ready environment right off the bat. So let's go ahead and open up the terminal. To get your terminal ready, I'm going to zoom in a little bit so you can see what's going on. I'm pasting in that big old command. It's the train a model command from that link I shared. Okay, start it running. Now, it's going to do a whole bunch of different things, and I'll explain what it's doing. That's kind of hypnotizing a little bit. So basically, what it is doing is we are performing this task. So we are going to train an image classification model. And this model will detect between 3 different classes of animal. And I've chosen them for a reason. So we've got, on the one hand, we have our Linux, from right to left here, we've got our Linux penguin, Tux. That's not Tux, it's just a cute penguin. But the penguins represent Linux. We've got a whale for Docker. And then we've got a little octopus, okay, for Wolfie, okay? And Wolfie is the smallest octopus in the world, because we like to keep things minimal at Chainguard. And so we're going to be classifying, basically, we're going to train, what we're doing over here is we're training a model that will detect between these 3 classes of image. And then we're going to run it on an image, and it's going to say, hey, it's either one of these 3 animals, okay? And I want to quickly show you, I'm pulling up another terminal real quick over here. Just show you what the data looks like. Octopus, penguin, CD, octopus, penguin, whale. So basically, we have 2 folders here. We have our training data. We have our validation data. It's a pretty small data set because what we're actually doing here is we're fine-tuning a model. So we have a ResNet model. I think it's ResNet 18. We've pulled it in, and we're going to fine-tune that model. It already has a lot of, this is deep learning. We already have a lot of image data in that model. And so really what we're just doing it is we're sensitizing it to these 3 classes of images, okay? It definitely already has plenty of penguins and whales and stuff in there, but we're kind of putting it over the top and making it really pay attention to those things. And so if we go into the train folder here, and then it has 3 classes, okay? And let's just check out the penguins because they're cute. And so this is the data for our penguins, and it's not that many images in the grand scheme. I think it's like a 40 or something, and that's enough to fine-tune this model. Okay, there's some really cute ones in here. Yeah, look at these guys, man. Too bad it's illegal to own a penguin in New York City, but and basically also these are realistic images, so it's not going to do that well on like cartoon images or whatever. Okay, let's see how far along we are so I can. Okay, it's actually going to take a while. I'm going to explain a little bit more. If it's looking like it's taking too long, I actually, can kind of fake this a little bit. But so why is it taking a long time? Basically, I made a choice here, and that is not to ask you to try to run this on GPUs. That is basically because unless you have a very specific environment set up, in GCP, AWS, you have a home lab. I'm betting some of you do, because that's who comes to these things. But probably you're using your laptop or whatever. Basically, if you want to run this in a CUDA enabled environment, but probably unless you've been careful about it, it's not the easiest thing to set up these environments. But if you think you have it, you can add the GPUs all flag. So if we have our command here, it would be, you would add GPUs all. So you would say GPUs all, okay? And you would add that, and then that would basically say, actually run this in a GPU environment. Then this training would take about something a little under 2 minutes, okay? But because we're using CPU here, sort of deliberately, things are going to take a little while. And actually, I'm feeling like this is going to take too long. We're about halfway through. And I want to make sure we get to everything. So you keep yours running. What I'm going to do is cancel mine out. But we are going to shut this down, and I'm going to kind of fake it here a little bit, just because it's taking too long. Image classification. I'm deleting the image classification folder that was created. And I am grabbing the completed version that I have sitting on my desktop, which is the exact same thing. Okay. Oh, I didn't even see here. Cool. So when you are done, when your model finally completes, which should be probably in, say, 5 minutes or so, you do ls here, and it should have this pt file here, and that is a pickle file. Okay, so the model is saved as a Python pickle file, which actually they're not the most secure files. This ecosystem has yet to mature, but we trained it ourselves, so we're not as worried as we could be. But there's definitely some security issues around models. Okay, and what we did here was we ran a PyTorch script on the training data that I showed you, and it created basically the model, which is a set of basically tensors. So basically, it's all matrix math. So it's just to really simplify things, lists of lists of lists in a giant file, and then we basically dump all of that into a pickle file that we can load in again. So now, once you have this, and it maybe your computer is faster than mine, maybe you're done, maybe you're still waiting. But what we're going to do is we're going to first we need to download a image of either an octopus, a penguin, or a whale, and then put it into this folder, this image classification folder. So you can do that if you want. You can go on the internet and grab one yourself, one of those categories. I do think you should probably grab a realistic image, not like a cartoon or a stylized image. But those will work the best because that's what's in the training data. Or we have a command here that will let you download them on the command line. So we have a octopus image that is downloadable with this curl command. Okay, so this curl command will save an octopus image into this folder. So I'm pasting it in. It's right below. So we have first the training command, and if you scroll down, we have a nice curl command for you here. So grab this one image of an octopus, and I'm gonna take a quick look at that, just so we know what it looks like. It's an octopus. It's nothing that special. Actually, they're pretty cool. And so that will be now in our image classification folder. And now we're ready to run the inference. Okay. Hopefully, you may not be because you're still training, but that's how this goes. And then we're gonna grab this this inference command. So that's basically, it's gonna take our model, it loads it into our PyTorch image in a volume. It already saved it to our host machine through the volume before. It's gonna load it in a volume, and then it's going to use that model along with the script that we have to identify whether that image is a penguin, whale, or octopus. And if you do choose to do this with another image, you may want to save the image. You'll have to change this last little bit at the end here. Instead of saying octopus.jpg, it should say whatever your image is called. And you should maybe consider simplifying the name, unless you're really good at escaping file names on the command line, which I'm sure some of you are, with quotes or backslashes. Then you're going to want to simplify the name because that will, mess up the command. Okay, so let's go ahead and run it. It's going to take a little second, and then it should spit out. And it said octopus. It should tell us what class it thinks the image is in. and that's octopus. Okay, so you could grab a whale and a penguin. I tried a whale earlier, and it said whale. There are definitely images out there that will trip this up. This is not a huge data set. I think it has, for each class, 40 training and 20 validation images, so it's not a huge data set, but it seems accurate enough. That's kind of the beauty of pre-training a model, is that you do take advantage of that underlying model that had a much bigger data set. So it's kind of impressive how little data these things can actually fine-tune on these days. We can also very quickly talk about CVEs in the image. But basically, the short version is we can use our Chainguard console as the quick version. Just logging in. And if we look at our PyTorch image, Gripe does take a minute to run on these, which is why I'm using our console. If we look at vulnerabilities, and this is something you can do with our image. We have SBOMs, which tells you all of the software in the image, which is pretty cool. That's in that tab. And a vulnerabilities tab that constantly scans the images. And the image is free of CVEs. Okay. So, and you could run this with Gripe. The Gripe scan will take about maybe a couple of minutes because these images are a couple of gigs. But it should spit out 0 CVEs as of today. Whereas the current official PyTorch is 1 critical, 5 high, et cetera. So these are much more minimal and less attack surface, and we currently have 0 CVEs, so they're low to 0 CVE images. Okay. Currently we have, I think it's CUDA 12 image with PyTorch with Python 11, and that's what's currently available. If you want different versions, older tags, or you want our service license agreement, then you could talk to us for those. Reach out to me, or just check out our website for our production grade tier, our production tier of these. But for now, you can definitely use these. This is a public image, and you can pull it and use it, and we will be bumping up those versions as new versions of Python, PyTorch, and CUDA come out. Okay, and I just want to also show you some good places to get started as you kind of continue this journey. Okay, and those are here. So first, I want to highlight our very cool course, Securing the AI ML Supply Chain. And this covers a lot. So from everything from the ecosystem around the regulatory ecosystem, FedRAMP, all that stuff, to what is AI, what is ML, to doing some practical hands-on stuff. And it'll also teach you how to scan images. So this is a kind of a one-stop shop for everything related to AI and your deployment and the AI supply chain. This is definitely not a mature ecosystem, so it's very cutting edge. So there's definitely from everything from model security we talk about and so on, and it's pretty fast-moving field. So I would definitely start here. If you want a more focused introduction to the PyTorch image, to getting ready with the PyTorch image, then you can check out our website, Chainguard Academy, where we have a getting started with the PyTorch Chainguard image. And this will walk you through a little more slowly than I just went here. There's 2 versions, which is kind of the big command version that I just shared with you right now. This does do a GPU by default, so you want to look out for that. You will either want a GPU-ready environment or take out that GPU's all flag. Or you can, there's a more interactive. So you can actually, that image that I just shared with you, it doesn't actually have a shell because it's hardened, but you can use our developer version of the image, the dev version, to run it interactively. And this will step you through that. So you can kind of see step-by-step how everything works, okay? So this is the place I recommend to get started. And I'll also say, Chainguard has other AI-ready images. If you want to work with the OpenAI API, for example, I recommend our Python, regular Python image is a great basis for that. If you want to, we also have MLflow and a number of other, and NVIDIA Nemo is one that you should definitely check out. That's conversational AI. So we have quite a few AI-ready images for you to check out, and more to come. Okay, so we have Triton server in the works and a whole bunch of other ones coming out in the coming months. So that's basically it. I hope we have a little time for Q&A. 12:37. I think that's actually pretty good on time. So let's go back to the, we can kind of look at Wolfie. We're not at goodbye yet, but we can look at Wolfie hanging out. Okay, but let's do Q&A. Okay, well, let's give it a second. While we watch the Wolfie, the smallest octopus in the world, dig a little hole. I bet there will be at least a couple of questions. Awesome. Yeah, take a look at the chat. I've also shared in the bit.ly link that I shared. So it's bit.ly/CG PyTorch. There are a number of links to these, to the AI course, to the Getting Started guide. You can create an issue if people are having issues. That's another good place to get started if you're, want to pull on this thread. Cool, no questions? Awesome. Yeah, we have a WordPress coming up. Yeah, Kirby's just let me know that we have a WordPress next month. So if you go to Chainguard Events Goldcast, let's pull it up. Okay, awesome. Yeah, I don't know that. Okay, yeah. So, but basically, our next Learning Lab will be on our WordPress image, and which we're pretty excited about. So if you know any PHP people, share that on social media. And Erica Heidi will be leading that one. So it should be a good one. Cool. Awesome. Yeah. Basically, in terms of we always have a latest image that is in our public tier. And we sometimes make some executive decisions about that, or holding things back for a bit. And sometimes that can make things pretty difficult in terms of the 0 CVE, pledge or whatever. But I would say a lot of those are on a case-by-case basis. So basically, that's like exactly like what we just saw this morning when I went to look at that high CVE for Python. And basically what we did there was a newer version came out that caused a number of different issues. So what our CVE team did is they went in there, they cherry-picked a version that was still very recent, but wasn't susceptible to that CVE, and that's what they merged that into our upstream. So basically, a lot of it is case by case, but it can involve different things from picking versions to, as long as they're secure, to issuing advisories, and the other thing is you can definitely use older if you're on our production tier. We have all those older tags and so on, so you can use, if something's breaking, you can use older versions potentially. But we try to walk a fine line. When we aim for 0 CVEs, it definitely does introduce, when you try to be on the cutting edge, things are definitely more likely to break. We know every organization is different in terms of their need to stay at 0. Some people need to stay at 0 because, say, they're working with FedRAMP or something like that. And then some organizations, they're like, well, we might just drop down a month or two to make sure everything gets resolved. We need stability or whatever. So we have that we have those tags available to you. And otherwise, we're trying to always walk that line between breaking and being cutting edge, which is not the easiest thing in the world. Cool. Yeah, of course. I'm sorry. I keep forgetting that. Yeah. So the question was, how about curation of images? How do we handle breaking changes? That was the question. So, and that's from Hans. Thank you, Hans. Cool. Anything else coming, Kirby? Okay, final call, guys. One more question. Awesome. Okay. Well, looking forward to seeing you all at the WordPress one next month. And also check our Chainguard events page for other cool events. Or Dan Warink Learns About X series is also pretty entertaining. All right. Thank you all.